Hey everyone, we are Group 3, and today we are going to discuss the different fields of instructions, breaking down the code that empowers your machine, describe the two major categories of control units, exploring their unique roles and functionalities, and discover the phases of an instruction cycle, witnessing the step-by-step process that brings your commands to life.
Computer instructions. Computer instructions are a set of instructions of machine language, which is the binary zeros and ones, that a particular processor understands and executes. Computer performs tasks on the basis of the instructions provided. An instruction comprises of groups called fields, and these fields include the operation code or opcode field, which specifies the operation to be performed, such as addition. The next one is address of operand, or the address field, which contains the location of the operand. Examples if it's in the register or memory location. And lastly, we have the mode field, which specifies how the operand will be located.
A basic computer has three instruction code formats, which are memory reference instruction, register reference instruction, input-output instruction. First is memory reference instruction. This instructions format uses memory addresses to perform operations like loading data from memory or storing data into memory. It generally involves a CPU accessing data stored in the computer's memory. Common operations include fetching data from memory, performing calculations, or writing data back to memory. Next is register reference instruction. This instructions format uses registers with the CPU to perform operations without needing to reference memory. Registers are small, fast storage locations within the CPU. The register reference instruction operates directly on these registers, enabling quick operations like data transfers between register, arithmetic, or logical operations. Next is input-output instructions. This instruction format is used for reading data from input devices or writing data to output devices. These instructions handle communication between the CPU and peripheral devices such as keyboards, printers, or displays. They are responsible for transferring data to and from external I/O devices, helping the system interact within the outside world.
Memory reference instruction consists of address field, opcode, and addressing mode. The address is a 12-bit field located in bits 0 to 11, and it specifies the location in the memory where a data or a particular instruction can be accessed or stored. The opcode is a 3-bit field located in bits 12 to 14 of the instruction format. It is represented by binary from 000 to 110. The addressing mode is a 1-bit field located in bit 15, and it represents the type of addressing. There are two types of addressing. If I is equals to 0, it indicates direct addressing, while if I is equals to 1, it indicates indirect.
Register reference instruction. The register instruction are represented by the opcode 11 with 0 in the leftmost bit 15 of the instruction. The operation code of opcode of instruction refers to a group of bits that define arithmetic and logic operations such as add, subtract, multiply, shift, and complement. A register reference instruction specifies an operation on or a test of AC accumulator register.
For input-output instruction, the bits through 12 through 14 should be equal. The operation code is 111. Bit 15, this bit determines the type of instruction. If bit 15 is 0, it's a register reference instruction. If bit 15 is 1, it's an input-output instruction. The remaining 12 bits specify the type of input-output operation or test. In summary, if the operation code is 111 and bit 15 is 1. It's an input-output instruction. If bit 15 is 0, it's a register reference instruction.
A set of instruction is said to be complete of the computer include the insufficient number of instruction each following categories. Number 1, arithmetic and logic shift instruction. So ayun yung nag-shift ka ng ilang ulit pa right and then nag-add ka ng 0 sa dulo nito. So left to right and right to left. Ganun yung pag-add ng 0 na kung ilan yung sinip mo, ganun yung mag-add. Kung ilan yung sinip mo, yun yung 0 na ilalagay mo sa dulo. So, sa number 2 naman, it's set of instruction of moving information from the memory and process registration. So, ito yung register type of memory na quickly transfer to sa yung type ng memory na nagta-transfer ng mabilis sa data at saka nag-i-store sa CPU. So, ganun yun. So, dito naman tayo sa pangatlo, instruction which control program together with instructions that check status condition. So, dito naman, ito yung nagmo-modify and tapos nagpapalit ng flow ng program na ginawa mo. So, dito naman tayo sa huli, input and output instruction. Dito naman nakalagay yung pag-i-input ng user direct sa computer, tapos pinaprocess ni CPU yung mga data na in-input mo.
Arithmetic, logic, and shift instructions provide computational capabilities for processing the type of data the user may wish to employ. A huge amount of binary information is stored in the memory unit, but all computations are done in processor registers. Therefore, one must possess the capability of moving information between these two units. Program control instructions such as branch instruction are used to change the sequence in which the program is executed. Input and output instructions act as an interface between the computer and the user. Programs and data must be transferred into memory, and the results of the computations must be transferred back to the user. Arithmetic instructions perform basic operations like addition, subtraction, and multiplication. Logic instructions handle operations such as AND, OR, and NOT, vital for decision-making processes. Shift instructions manipulate binary data by shifting bits left or right, used for tasks like multiplication or division by powers of 2. Program control instructions include jumps, loops, and conditional statements that allow dynamic flow changes based on logic outcomes. Input-output operations manage external devices such as keyboards, displays, and storage, ensuring communication between the computer and the peripherals.
Lesson 2, Design Control Unit. Meron tayong 2 categories dito sa ating Design Control Unit. Una is Hardware Control, then sunod is Microprogram Control. Ang Hardware Control, ito yung makikita natin sa ating mga PCs, remotes, marami, cellphones, etc. Halimbawa nito ay processor, memory, mga ganyan. Yan yung hardwire control. Halimbawa, magpapakita ko na example kung ano yun. Halimbawa, ito siya. Hardware control siya. Ibig sabihin, siya yung pinagkokonikan ng mga components para siya umandar. Then sunod is microprogram control. Ang microprogram control ay ito yung nagpapakita sa ating ng mga sequence kung saan siya pupunta. Kunyari, sa pag-ano ng CPU, saan mo i-connect yung yung RAM, yung mga ganyan, power supply, and everything. Magpapakita rin ako ng example at ito yon. Ito yon, ang microprogram control unit function, ibig sabihin, ito yung nagpapakita ng control memory and command. Ibig sabihin kung saan mo siya inilagay, dun siya yun yung ipoprogram niya. Yun yung lalabas sa kanya.
Hardware control consists of two decoder, a sequence counter, and a number of logic gates. It manages a CPU executes instruction using PIC circuits. It includes two decoders that have interfret commands. An instruction fetch from the memory unit is placed in the instruction register IR. IR is a temporary storage for CPU. The component of the instruction register includes I bit, the operation code, and bit 0 through 11. The operation code in bits 12 through 14 are coded with 3x8 decoder. The operator code opcode is a part of instruction that tells the CPU what to do. The output of the decoder are defined by the symbol T0 through T7. The operation code at bit 15 is transferred to a flip-flop designed by a symbol I. The operation code from bits 0 through 11 are applied to the control logic gates. The sequence counter SC can count a binary from 0 to 15. It helps decodes run or function the codes.
Microprogrammed control. The microprogrammed control organization is implemented by using the programming approach. So in microprogrammed control, the micro operations are performed by executing a program consisting of micro instructions, and the creation of a set of control signals is dependent on the execution of a micro instruction.
The control memory address registers and specifies the address of the micro instruction. The control memory is assumed to be ROM, which stands for read-only memory, within which all control information is permanently stored. The control register holds the micro instruction fetched from the memory. The micro instruction contains a control word that specifies one or more micro operations for the data processor. While the micro operations are being executed, the next address is computed in the next address generator circuit and then transferred into the control address register to read the next micro instruction. The next address generator is often referred to as a microprogram sequencer, as it determines the address sequence that is read from control memory.
A program residing in a memory unit of a computer consists of a sequence of instructions. These instructions are executed by the processor by going through a cycle for each instructions. In a basic computer, each instruction cycle consists of these phases: fetch, decode, read, and execute, and it repeats in a cycle. Instructions consist of two parts: the instructions itself and the memory address. So it fetches the instructions from memory, decodes the instruction, then reads the effective address from memory, and lastly, it executes the instructions, and it repeats in a loop in a cycle until there are no more instructions left in the memory.
Imagine your computer as a brain. It needs a way to receive information and share its results. That's where input and output devices come in. Input devices are like the computer senses that let us communicate with the machine. For example, a keyboard let us type commands and a mouse let us point and click. Output devices are like the computer's voice. They show us the results of the computer's work. A monitor displays images and text, while printers produce physical copies. Input devices brings data into the computer. Output devices display the results. Together, they form a bridge between the user and the machine. This diagram illustrates how input and output devices interact with the computer system. The input-output terminal. This is a generic term for any device that can either input data to the computer or output data from the computer. In this diagram, the specific input-output terminals shown are the printer and a keyboard. Serial Communication Interface. This is a type of interface that sends data one bit at a time, sequentially. In this diagram, the serial communication interface includes a receiver interface and a transmitter interface. The computer registers and flip-flops. These are electronic circuits that store and manipulate data within the computer. The diagram shows two specific registers, OUTR and INPR. AC. AC stands for accumulator. An accumulator is a register that holds intermediate results during calculations. Input. Data from the keyboard is sent to the transmitter interface, which then transmits it to the INPR register. Data from the OUTR register is sent to the receiver interface, which then transmits it to the printer.
Design of a basic computer. A basic computer consists of the following hardware components. So, these are the following components. Number 1. A memory unit with 4096 words of 16 bits each. Number 2. Registers. Accumulator, data register, address register, instruction register, program counter, temporary register, sequence counter, and lastly, input and output registers. Flip-flops. An FGI and FGO are corresponding input and output flags, which are considered as control flip-flops. The two decoders, a 3x8 operation decoders and 14x16 timing decoders. And also, it has a 16 bits common bus, control logic gates, and lastly, the logic and other circuits connected to the input of accumulator.